Alrighty, let me start the show. Okay, so so Romeo asked me to give a presentation to you, Landon, and some of the Red Hat colleagues of yours. And so welcome. I'm going to introduce you to Jupyter Enterprise Gateway today. A little bit about me. I've been in the Jupyter ecosystem for about the last well, since 2017, really. So about the last 5 years, almost six. They're undergoing a new governance model, remodeling, if you will. And with that, I will be a participant on the Jupyter Server Council, the Jupyter Kernels Council, and then as of this week, the Jupyter Standards Council. So I feel that gives IBM a pretty good foothold in the back end portion of the Jupyter ecosystem. We also have some council members in the Jupyter Lab, and other colleagues like Kirsten and stuff will undoubtedly be evolving into some council roles as time goes on. So anyway, we're pretty active in the Jupyter ecosystem as a team here at IBM. So today I wanted to give a background on Jupyter Notebooks that kind of set the stage for what we want to talk about in Enterprise Gateway. We'll talk about how we got to Enterprise Gateway in the first place. Then I'll give you some details on Enterprise Gateway, and then I wanted to talk about the future roadmap a little bit as well. So I'm assuming everybody's familiar with Jupyter Notebooks. They're pretty prevalent in business now. They were mostly based on education and science. They were kind of founded in academia. Many of the founders of the Jupyter project were and are professors at universities. And that's kind of how this all kind of got started. So in a nutshell, they allow you to have computational documents. So you can put widgets and whatever, you can perform calculations, and then they're rendered right there in your web browser. So it brings computation to a web interface. They're language agnostic. You can have different pieces of code within your document running, and the item that's on the back end that's receiving those computational requests is what's known as the kernel. And so the kernel executes the source code and it returns the results. And as I said, there are many implementations of Jupyter kernels, over 100, across dozens of languages. There's, Enterprise Gateway focuses on the data analytics languages, Python, R, and Scala. So the kernels that we will be referring to later on are essentially those three kernels. We don't preclude anybody from using other kernel languages, just that there is some bootstrapping layers that do need to be implemented for that to happen. So the way the server communicates with the kernel is it goes through this ZMQ or 0MQ ports. And there are 5 ports that are part of the message protocol. And these ports are allocated when the kernel starts, and one of the low-level Jupyter packages is what communicates with the kernel. The front end communicates with the server via a WebSocket. There are some lifecycle management actions that do take place over HTTP. But the communication with the kernel itself goes across a WebSocket to this lower level package, which then decomposes the message in the WebSocket to the appropriate channel. It knows which channel based on the content of the WebSocket payload to route the request. So some of the key pieces to keep in mind here is that in the native Jupyter ecosystem, all kernel processes are local to the launching server. And so and then there's a kernel manager that's implemented that controls the life cycle of the kernel. Now that manager is simply sitting on in Python a p open interface, which is basically the interface used to talk to a process, a Python process. So you can send signals, you can shut it down, you can pull that it's alive or not, that kind of thing. And so this kernel manager deals with the lifecycle management, but the rest of the communication happens across the 0 and Q ports. And so one of the early gateway projects is called Jupyter Kernel Gateway. And as it became evident that the implementers of Jupyter Kernel Gateway wanted to decouple the kernel lifecycle management from the user's desktop, and essentially move the lifecycle management closer to the computational cluster, if you will. And so with Kernel Gateway, what happens is the kernel lifecycle management and the WebSocket management are essentially proxied to another Jupyter server. And all Kernel Gateway is a Jupyter notebook server without content support, without sessions. It's a headless kernel server, if you will. But the processes are still launched and they're still local to that Kernel Gateway server. So as the needs arise, we can still run out of resources running with Kernel Gateway. And so back in 2017, IBM was realizing that many of the data analysts out there in enterprises need high computational high computational resources, and they found that their Spark drivers were just getting bogged down, and the driver was always on the launching server. Even though Spark, if you could launch into Spark, the executors might be in the Spark cluster, but the driver is really the primary consumer of the resources and has to mitigate and manage all the executors and things like that. And so there was this need that if we could only launch the kernel into the computational cluster, that we might be able to get a big win here, and that might open the door for other environments. But it was really Spark and Hadoop clusters, Yarn Hadoop clusters, that we were focused on early on in 2017, and when we became an incubation project, and then in 2018 we were promoted into a full Jupyter, recognized as a full Jupyter project. And then with this governance remodeling, we've been moved into the Jupyter Server Organization as of last year. There's something I was going to mention here, but it just slipped my mind. All right, let's move on. So with Enterprise Gateway, we introduced the ability to launch the kernel into the cluster. So now your Spark driver is running on one of the nodes of the cluster, and the node that it's running on is determined by the resource manager, not by Jupyter. And so when we launch a kernel into a cluster, we don't know where it landed. But by using the resource manager API, we can discover its location and then know how to communicate back with it. So when we launch a kernel, we also tell it where to reply with its connection information. And then we also will enlist the services of whatever the underlying resource manager is to both discover the kernel, but also manage its lifecycle via the resource manager. And to do that, we introduced this notion of a process proxy. And so what we found was, well, the whole lifecycle management is predicated on this popen interface, which is just a simple Python process interface. So if we can abstract it and allow for a pluggable abstraction to that kernel process, then we have a place to hook in things like, Hadoop Yarn API calls to discover where the kernel landed, or to terminate the kernel application. And so with this process proxy abstraction, we were immediately able to do things like SSH across a configured set of hosts. And so we can round robin across some hosts and determine what host we're landing on based on our algorithms. But we can also launch into a Hadoop Yarn cluster using our Yarn cluster process proxy. That opened the door for other things. And so we introduced containerized process proxies, where we're able to launch into Docker and Docker Swarm clusters or environments. Kubernetes was a natural evolution once we had the container stuff done. And then since then, we've had contributions from the community to do custom resource descriptions or definition process proxies that derive from the Kubernetes process proxy. So they've gone and extended the Kubernetes process proxy with something that understands the CRDs, and with that, they've even contributed the Spark operator process proxy for more easily launching Spark applications. Now, the Kubernetes process proxy can still manage Spark in Kubernetes, but the Spark operator is a little bit more natural, way to manage your Spark applications. And then, of course, our IBM Spectrum Conductor folks, which is modeled very similar to Hadoop Yarn, they implemented their own conductor cluster process proxy. And so this has really been a nice proof of concept that has evolved into something that is very useful and extendable. I don't know if there are other process proxies out in the world. We don't really care. We've given the ability for people to add their own as they need. I could see things like Slurm or other kinds of high computational cluster process proxies being invented for with this model in mind. So other things that Jupyter Enterprise Gateway adds that aren't available necessarily in the rest of the ecosystem are some configurable options for kernels. And right now it's very limited. That bottom line there, we desperately need parameterized kernels. And we have a lot of ideas for how to go about doing that. It's just we're constrained by some time and ability to get this into the community. But prior to that, we can do some configuration through kernel environment variables. So anything prefixed with kernel underbar will flow from the client through the gateway and be available in that kernel process. So they can also be used while the kernel is being launched. So we could have things like kernel underbar CPUs, and that would allow the launching mechanism to recognize kernel underbar CPU and set the number of CPUs for that Kubernetes pod, for example. And then we also, well, kernel specifications are across the ecosystem. So every kernel has a kernel spec that has the launching information in it for that kernel. We have gone and extended that kernel specification to include things like which process proxy to associate with this kernel, and other options. And so this leads to these static configuration items lead to t-shirt sized kernels. So you could have your small kernel, your medium, and your large kernels that might use GPUs and CPUs and things like that. We also, in our Kubernetes integration, we also expose the actual pod YAML file. It's a template file that is then used to launch the kernel pod. And so for each kernel, they have a separate pod YAML file that can be tuned by an administrator to add additional Kubernetes resource and attributes to that decorate the pod when it's launched. But back to parameterized kernels, what we really want is the ability to specify a JSON schema, or this is our idea that we want to get into the ecosystem, but have a JSON schema that describes the parameters that's in the kernel specification. Each of these kernel specifications go to the front end. They go to lab, they go to notebook, and then given that JSON schema, we could build a front end that prompts for the various parameters that kernel wants to expose. And they would have their default values, they have their data type, they even have descriptive strings. I mean, you could build a rich UI with that. The user would then set their parameters, and the values would then be sent back into the start request. And then the process proxy likely would be the thing that validates the parameters, because really most parameters are really about the environment that the kernel is running in, not necessarily the kernel itself. So things like CPUs, GPUs, and memory aren't anything the kernel really worries about. That's more of the process proxy that is responsible for creating the environment in which the kernel runs in. So we hope to at least start on that probably late this year or early next year, but it needs to be done. That's probably the number one item, even outside of Enterprise Gateway, that people want is, hey, I need to set a couple GPUs for this one notebook that I'm running. How do I do it? Yada, yada. Excuse me. Some other things we've added are things like high availability and disaster recovery support. So when a kernel gets launched, we persist the connection information and all the state that is necessary to hydrate the kernel back up in another location. And so right now it's mostly active passive kind of stuff, but we do have the ability now to dynamically detect that when say you had a couple different EG servers running against your cluster, if the request for lifecycle management were to go to a different server, we have the ability to detect that kernel server doesn't really know about that kernel. Let's go hydrate up the information from our persisted store and connect to the kernel from that server and manage its life cycle from that server. So we're getting there. There's still some rough edges to work out on that, but that's one of the things that I believe Enterprise Gateway should provide, that the rest of the ecosystem, being more single user based, won't really need. We also cache our kernel specs. They get pulled from the lab. I'm sorry.
Sorry, a quick question.
Yeah.
So for the HADR support, disaster recovery, is the user access to their specific kernel pods, I'm talking in terms of Kubernetes, is it still routed through the enterprise gateway, or do they gain direct access? So if any of the
It'll always be their requests always go through an EG server somewhere.
okay.
Right.
And I'm talking about, so outside of spawning creation, once it's running, it's always going through an EG server.
Yeah, it has to go through that WebSocket, and
Okay.
that WebSocket, has to go to the server. One of the things that, over time, you start thinking about, wow, what if we could do this? What I'd really like to do someday is move that WebSocket handler into the kernel and into the launcher that is, a colleague or a sibling to the kernel wherever it landed. And then you just have a single port you're going through, and let the 5 ports happen on the pod, on the kernel pod, right? So the protocol can still be adhered to. We're just proxying the WebSocket one more step along the way, all the way directly to the kernel. Then you could expose the kernel as a service, if you will, with a single port that's the WebSocket, and then you could really be communicating directly from a messaging standpoint to the kernel. But right now, it's got to hop through a Jupyter server to get there.
Okay, thank you.
Good question. Yeah, so lab pulls the kernel specs. They're fairly static pieces of information, but you can add a kernel spec after you've started the server, and it will be picked up dynamically. So they pod about every 10 or 15 seconds. That ends up being a file system read of all the kernel specs and all that stuff. So we go ahead and cache them, and then behind that, in that cache, we have a watch daemon that's watching the file system for changes and updating the cache on the backside. We've also added some dynamic configuration capabilities, so you don't have to restart the server to enable logging, for example, or things like that. So some of these, the kernel spec caching, the dynamic configuration, I would like to move into Jupyter Server proper, because I believe that's something that the rest of the ecosystem could benefit from. And so I kind of view Enterprise Gateway as this proof of concept testing ground for different ideas. And so it's kind of worked out well in that sense. So, we get more than just the ability to manage remote kernels. We also get this ability to check things out and, play around a little bit. One of the other things we do offer is authorization. And I say that in the application sense strictly, but authorization at the kernel specification level. So I can configure kernel specs that are only available for certain users, and other users will not see those kernel specs as an option to be launched. And so we can deny and allow users at that level. Now they're just names. We don't really have authentication going on much at Enterprise Gateway. It's assumed you got a reverse proxy or other things that are doing the authentication for you. And so we have a kernel username that comes across in the request, and that's what we use to manage things like this, quote, application level authorization. Whoa, I guess I have a duplicate slide here. So we've already covered this. Oh, wait, it went back. Oh, I did delete instead of forward. Sorry. So I went backwards. All right. So future roadmap. So one of the things that I introduced into the base framework are kernel provisioners, and all a kernel provisioner is a redux, if you will, of process proxies. But we don't have to override the kernel manager to do any management. So it's all baked into the base framework, and they're known as kernel provisioners. And so what that enables applications to do is start creating their own kernel provisioner, which then it exposes things like Kubernetes pods just to Jupyter Notebook applications. You don't need a gateway. But what you still need for at least these remote kinds of provisioners is you would need the notebook server or the Jupyter server to be also on the Kubernetes cluster running as a pod. For some, they still want their notebooks on their desktops and their server on their desktop. And so there will still always be a need for a gateway server. I can, which separates the kernel server from the user's desktop. So we still have a need for a gateway. There will still be some enterprise features that are in a gateway that aren't in the server. But the heart of Enterprise Gateway today is this process proxy architecture, which is now available in the form of kernel provisioners. And finally, I wanted to leave you with some resources. Here are some links to our repository, to our documentation, to Jupyter as a whole, the messaging protocol if you wanted to look into that, and then kernel provisioners, the documentation for that. So with that, that's all I've got. And do you have any further questions, Landon?
Yeah, I had a question. So obviously we're very interested in like HA, disaster recovery, which is kind of one of the major issues we ran into with Jupyter Hub that triggered our kind of movement to notebook controller. How is the Enterprise Gateway managing or keeping track of the pod lifecycle? And we're talking strictly in a Kubernetes environment. So if there are, we'll say 100 notebook servers running, what is the Enterprise Gateway service or server using to kind of keep track of what's running, what's available?
Right. So EG is only managing the kernel pods, not the notebook servers. So you'd still have your 100 notebook servers, presumably talking to one or more EG servers in order to get the kernels running outside of the notebook server pod, if you will. Right. Did you get that picture? So Hub is running in Kubernetes, right? For your
Right.
case. And then it's just a spawner of notebook servers. And then the notebook servers are configured to talk to an EG server so that the kernels that are spawned by the notebook server aren't in the notebook server pod, they're in their own pods. So EG uses a persistent store to track the kernels that it has launched. And that persistent store presumably is shared across whatever EG servers are part of your HA configuration.
Okay.
And then today we do require session affinity because really kernel management is stateful. The kernel manager running on a given EG server is dedicated to the kernel that it launched. Now, if that EG server were to go down and a request for that same kernel happened to hit another EG server, then that EG server would be the new affin server to that kernel. It would detect that the kernel is not being managed by that server. That would instruct it to go load the kernel information from the persistent store and hydrate up a kernel manager on that server. And then the affinity requirement would be dedicated to that EG server for the rest of that kernel's life cycle.
Okay. Yeah. So I think, apologies, I'm having to rethink my understanding of kind of Hub and notebook servers and the terms we use. So this is making more sense. So I think I was equating one user to one notebook pod, and Jupyter Hub would manage the notebook pod. But I think you using the term kernel. For me, that's always been a user notebook pod.
Yeah. So think of a kernel as a actual notebook, because every notebook you open has a kernel process behind it. And so as soon as a user and if the user is only going to open one notebook, or that's kind of their working model, there's really no reason for EG. They can use the resources on that local notebook server pod and configure their pods accordingly for that particular notebook. But as soon as they start wanting to open up, 3, 4, 5 notebooks at a time, all those resources are going to be in that one notebook server pod, and that's where an EG server makes sense for people.
Right. Okay. So this is essentially allowing a user to have essentially distributed workload across different kernels.
Exactly. And one of the ideas is, even in Kubernetes, you could reach out and launch a kernel on a Hadoop Yarn bare metal cluster, for example. That kind of thing. That's only a proof of concept. We don't have the I don't know if we've ever done that before, but the workings should be available for that to work. We expose the port on the EG server that needs to receive the connection information for wherever the kernel landed. So if the kernel happens to be running outside of your Kubernetes cluster, you would expose that one port, and it's the same port across all kernels that are launched by EG. You would expose that one port as a service port that could then be communicated with and the connection information returned. Then once you have that connection established, you should be able to talk to the kernel, even if it's outside of the Kubernetes cluster. But again, that's theory at this point. I don't think we've ever, I haven't even tried getting that to work, but that's the idea behind the single response address feature that we added.
Okay. So if they're working in, say, a Python kernel and they have a process proxy for, I guess, Spark or something else, the expectation is the user is communicating however we spawn those kernels or the EG server spawns them. The expectation is that those communication channels are automatically set up. So within any given notebook, actual notebook, if they want to, submit a Spark workload, they don't have to do anything specific. They already know which ports and kind of where to send that Spark job off to.
Yeah, exactly.
Okay.
So yeah, I mean that's really the resource via the resource manager, Yarn, Hadoop, or Kubernetes, Spark on Kubernetes, whatever. And then we also will build a Spark session for them as well for those kinds of kernels. So they'll have a Spark context right away. When the kernel is available, once it's loaded and stuff, you can type sc.version and have your Spark context right there.
Okay. So I guess to revisit my earlier question about if we have 100 notebook pods, so I'm just going to say users. So if we have 100 users and they could be running one kernel, maybe it's just a simple Python kernel, or it could be kind of Python plus R plus something else. Is it my understanding, is it correct that would be one EG server per user?
You could configure it that way. That's more of the kernel gateway model, but we would recommend for EG that you have one EG server per hub or per set of notebook servers, or one or two or three, some limited number.
Right.
But they're really designed to be multi-tenant. Because they're really just routing requests to a different kernel, and the kernel has the isolation necessary for that particular request.
Okay.
Excuse me.
So yeah, go ahead.
No, I was just, I was thinking of something, but I can't. Never mind. filling the void of blank space.
No, it's starting to make more sense to me. So yeah, I'll definitely look into this. It's interesting. I know for our needs, I guess our workflow, yes, right now we're locked into the notebook controller, which is a very simple model. because we have a need for obviously HA, but also authorization for access. So those are kind of our two big things that's our number one priority. And then the added features for this enterprise gateway are intriguing. So yeah, I'll definitely look into it.
Yeah, and the reason I used quotes around the authorization topic was, we're really just using names. I had a PR that I was toying with to introduce a tenant ID. And a tenant ID would be something that flows from the notebook server, and it would allow us maybe to partition at least the kernel specifications by a tenant ID. So if you had different groups, say, using your cluster, and each group had a different tenant ID, but multiple users within that group were the same tenant, if you will, then you could see a world where even the kernel specifications are tenant based. And then within that kernel specification, that single username makes a lot more sense because it's just the user at that tenant. Whereas if we just had usernames across all kinds of tenants, there's going to be more than one Bob in the world and stuff like that. So, there probably needs to be some namespacing that has to happen to really get into enterprise or, well, hosted environments, if you will, that would share a cluster across tenants. But if it's dedicated to a single tenant, then the naming that we have today might work fine. The thing I wanted to mention earlier was I did recently learn that we have there are customers, well, not IBM customers, there are users of the open source Enterprise Gateway project that are running with 1,500 kernels in off of a given gateway server, which was really nice to hear. They say once they get up to that level, they start running into resources, and it's probably because of the ports. And each kernel requires 5 ports on a host, yada yada. So you start doing the math there, and it can get it can add up. But they've had a single EG server managing 1,500 kernels, which is pretty nice.
Yeah, this is nice. Yeah, we'll definitely, I guess, when we get a chance, look into it.
Yeah, and I'll shoot you this slide deck so you can have these links active. You shouldn't have to type these in.
No, this is nice.
Cool. Well, thank you. All right, I'm going to go ahead and stop the recording, and then I will stop sharing. So, maybe I'll do the stop sharing first. All right. I'm not sure how to stop the recording here. Here we go.
Unless, yeah, only